Cristiano Ferreira. I'm a games and graphics developer evangelist with Intel. This video is about why you'd want to disable the renderer component on your fully transparent game objects in Unity. Although it's not immediately obvious that you should turn off the mesh renderer component associated with a fully transparent game object in Unity, those kind of draw calls will actually take up almost as much system resources as the semi-transparent draw call would. There are a lot of instructional videos out there showing code examples like this. What this code is doing is fading the myRender variable's associated materials alpha value to 0 over the course of 4 seconds. A very common use of code like this is for damage indicating flashing vignette effects. For instance, if you get hit, you may want to have the screen fade in red around the borders and then fade back out. In this scenario, once the full screen quad that you're fading out is fully transparent, it's actually still rendering. The engine has no way of knowing your intentions and will not be able to stop a fully transparent draw call. The fully transparent draw call will actually go almost all the way through the graphics pipeline. These kinds of situations can add a lot of unnecessary overhead if the renderers associated with the effects are left on. Running this application with the GPA System Analyzer tool, you can see that toggling fully transparency to semi-transparency does not result in a significant shift in GPU time. It seems to stay around 22.3K. If we want to dig down and compare individual frames between semi-transparency and full transparency, we can take 2 captures and open them up in the GPA Frame Analyzer. So I've opened up the Frame Analyzer tool on the scene with the semi-transparent game objects. Each of these bars shown up top represents a separate draw call. We can search through to find where the semi-transparent objects are being rendered and select them to get the combined GPU duration. If we check out the render target view, we can see that the highlighted draw calls are in magenta, and these represent our semi-transparent game objects. When you select multiple draw calls in this view, the GPU duration metric shown in the bottom right indicates the combined draw call time for all of these objects. So if we see here, we can see that the combined GPU duration for all these draw calls is around 7,600 microseconds. Let's remember that as we go back to the other frame with the fully transparent game objects. Here we are opening up the fully transparent frame file. So when we look at this frame capture, you can see that the draw calls look almost identical. I'll highlight the same ones and we'll see how that's reflected in the render target. So even though you can't see them in the final render target view, you can see that these draw calls are still highlighted and showing up here. Now when you look at the GPU duration metric in the bottom right hand side of the screen, you can see that the total draw call time for all of these game objects was more or less the same as the one in the semi-transparent frame capture. Now I'll show you how to make sure that you don't render fully transparent game objects in code. The solution here is very simple. Once you've completely faded out your transparent objects, just disable the associated renderers. This will ensure that you aren't issuing unnecessary draw calls and all will be right in the world. That's it. Be sure to check out all your draw calls in GPA and make sure that you aren't rendering any fully transparent objects to save yourself some frame time. Thank you for checking out the video. For more information, feel free to check out the links in the description below.